Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome back to another episode of the Reliability Matters podcast. I'm so glad you're with me today. For those of you who are counting, this is episode number 125. As all of you are well aware, this show is all about reliability, specifically reliability of circuit assemblies. One challenge that seems to be persistent within our space is design for manufacturing, or DFM. If you're a contract manufacturer, I have no doubt that you've had the experience of being asked to build a product that seems unbuildable. One example that rings true in my world was the introduction of the bottom terminated component, or BTCs. BTCs are marvelous components because all of the lead terminations are below the part. They allow for highly dense component placement and highly miniaturized assemblies. They also present a number of unique challenges in reflow, in many cases voiding, cleaning, and inspection. Unlike other industries, we are not immune to the introduction of new technologies that may lack the implementation knowledge. We then spend the next several years at technical conferences and symposiums learning how to implement these new technologies. There are many acronyms in our industry that begin with DF, designed for testability, designed for mechanical assembly, serviceability, reliability, and so many more. So many, in fact, there's a placeholder acronym for all of the various design fors referred to as DFX. Perhaps the holy grail of DFX is DFM, designed for manufacturability, as it encompasses so many aspects of assembly. To help us understand what exactly is DFM, I invited Andrew Williams to be my guest on this episode. Andrew Williams is the engineering manager for electronics manufacturing at Pride Industries. He has more than 30 years of experience in manufacturing and design and holds an SMTA process engineer certification from SMTA, and he's also an IPC certified electronics program manager. Andrew is a guest lecturer at UC Davis and Cal State University Sacramento for supply chain management, operations, and TQM courses, and speaks frequently on DFM, DFS, and other DFX topics. And today, he's my guest on the Reliability Matters podcast. Well, hi, Andrew. Thanks for joining me today.
Yeah, thank you. Glad to be on.
I'm glad you're here. So let's kind of start let's establish a foundation. You work at Pride Industries. I've been to Pride Industries. I had the distinct thrill of getting a tour through the plant, and this was several years ago, and I think you've just gotten bigger since then. Tell me about Pride Industries and how it is unique among other things, contract manufacturing.
So one of the main things that separates us from most contract manufacturers is that we're actually a nonprofit organization. We're a social enterprise with a mission to create employment and employment opportunities for people with disabilities or other barriers to employment. So our workforce on our production floor in electronics manufacturing, for example, is made up of a large group of people with documented disabilities that have been integrated directly into our workforce and our processes. And we strive very heavily to ensure their success through our programs as a social enterprise and improving the community with what we do.
Yeah, that really struck me when I was there. When I went up there, I don't think I realized that. And or I don't recall knowing that ahead of time, and it was such a joy to see so many people really enjoying what they do, having a sense of career purpose and things like that. And it's definitely unique, particularly in the high tech world. And it may be less unique in other spaces, but in the high tech world, it's definitely unique. And it kudos to Pride and its team for choosing to start that type of organization. Design for manufacturability, DFM. You are your company's expert in that subject line. Tell me about the genesis of how you got interested in design for manufacturability. Was that your goal in your early part of the career, or was it due to frustration that you couldn't build what people were asking you to build, and someone needed to step up and fix it? Give me a little bit of history there.
It's a mixture of a lot of things. I guess as a process engineer or manufacturing engineer, to really get the best process available or capable for a product, you really need to kind of marry up the design with the manufacturing process. And unfortunately, most PCBA designers don't have the same level of manufacturing knowledge as they do design knowledge. And so some of those manufacturing characteristics kind of get left behind when they're doing a design for a product, specifically PCBAs, or also electromechanical or cable assemblies that can apply as well.
Yeah.
And so I guess you could say in some manners we were forced into it, because to really get the best process flow, you need to work with designers to improve some of those challenges that mitigating them in process is maybe possible, but really leaves challenges for the long term.
Sure. Going back to something you mentioned earlier, I meant to say this before I asked you that last question. Pride is purposely a not-for-profit organization. It's just kind of ironic because there's a lot of contract manufacturers out there that are nonprofit, but that's not their intention. The profit margins in this industry can be rather thin. It's a tough industry that we are in, because every year our customers and consumers expect the products we buy, the electronics products we buy, to be half the price, last twice as long, half the size,
right,
almost year over year over year over year. It really pushes the boundaries of how much more cost can we get out of this stuff, and so it's definitely, for many, not for all. There are segments in our space that have plenty of profit margins. I'm probably thinking of aerospace and military, right, and stuff like that. But consumer electronics in particular, very fine margins there. Okay, let's kind of start at the beginning. Let's define a few terms. Almost everyone in my audience are in the electronics manufacturing space, but not all. And even some of those, maybe some newer people to this industry, may not have heard the term DFM before. And others that have been in this industry for a long time and perhaps might be a little bit jaded may not believe in DFM. That it actually exists. So let's define the term. What is design for manufacturability? What's the goal in that?
No, that's good, because there is kind of a lack of a gray area for people who know or don't know it. It's either you know what DFM is and you use it routinely, or you may have never heard of it or is not quite implemented. So in its basic form, design for manufacturability is designing with the manufacturing process in mind, not just the product's purpose. So you're taking in that manufacturing capabilities, process, equipment, materials, etc., in mind as you're designing a product. From an advanced perspective, it's designing a product to take advantage of the most efficient manufacturing processes or equipment or techniques while meeting the product's purpose. So that's being much more in tune with what equipment's available and designing your product to get the most out of your product, because you're leveraging maybe the state-of-the-art equipment or some features that are very new that you can, that your design is capable because there's equipment available to produce it.
Right. And what are some of I'll divide it into two categories: the poster child reasons for DFM, the kind of like Captain Obvious reasons, right, and what are some of the other, maybe less appreciated, less understood, more subtle benefits of DFM?
So pretty much the obvious is eliminating process challenges that can be created from a poor design. So that means a product can be ran through a very efficient manufacturing process. So of course, that's going to result in a higher level of quality and consistency of that process. that can feed in or correlate with total manufacturing costs that are lower. And sometimes it can actually reduce the build duration, which starts bringing up the topic of on-time delivery. Some of the lower level or maybe not well-known benefits may be things that we're starting to hear about now, which is part availability, eliminating some risks that may come up in the future, because using a very custom component as opposed to something with a common footprint, depending on which path you choose, could develop a DFM issue in the future, depending on part availability. So those kind of benefits are a little bit less known. But like, as you said, usually the red flags that are obvious, those are the ones that most people are aware of when, viewing it from a DFM perspective.
Yeah, it's interesting. Supply chain is not something in normal times that we think or worry much about. In current times, it's certainly the kind of the top of the concern pyramid there. And I'm sure today there's probably a few more people that wish that if they had a DFM program that it had incorporated, the possibility of supply chain issues and things like that. I'm a big fan when I designed our equipment starting 32 years ago, and I don't do that so much anymore. They kind of don't let me do that anymore. But I basically said I can build anything from parts I can find at Home Depot. That was in the early days of my company. We were a bootstrap company, and we were building specific assembly products for our industry. And I was a big believer in sourcing parts that are readily available, and particularly parts that were not specifically designed for our application use, and more consumer use, and that allowed us to swap parts, that allowed us to change from brand A to brand B without any negative reliability effect. We don't really do that anymore. We can't. Our products have gotten far more sophisticated and more customized and things like that. But that was my goal to if I can buy it out of the Grainger catalog or the local hardware store, we'll go there first, right? And so maybe, although I didn't even know the acronym DFM back then, maybe there was a little bit of DFM in me. Who's responsible for DFM typically at a company?
So typically at its base level, the PCBA designer is responsible for DFM characteristics by means of maintaining a robust design rule checklist in their CAD software that they're using. Obviously, that's going to be a smaller base of DFM solutions because that's not the main purpose of design rule checks in CAD software. So in most cases, the largest amount of the expertise is going to be found with the manufacturing engineers that are directly involved with launching those products onto a manufacturing floor or with an EMS provider, depending on the type of relationship. So that's, I guess, something to say also is DFM doesn't only apply to people that are outsourcing their designs. It applies to anybody designing a product that's getting moved to a manufacturing floor. But in our case, as an EMS, our customers are doing the designs. And so they normally will look to us for that DFM input and feedback because their designers are very well skilled for bringing a product to life from a concept, but being able to build it, they may create some challenges. The best design may not always be the best manufacturable product.
Sure. I would imagine everyone has their own silo that they're responsible for.
Yes.
The board design people have to create a board that maybe has to fit a certain form factor, that has to, perform certain types of tasks, and the assembly people, they don't care much about that. They care more about, can we assemble this stuff? And the people who source parts have other concerns over, how much of this is extremely custom, how much of this is with a sole source vendor, things like that. So I would imagine that best practices of DFM incorporates almost like a task force of design engineers, manufacturing engineers, people from the assembly floor, people from the purchasing departments, things, and even in some cases customer input. I would imagine a coalition of input probably helps in a DFM process. Is that your experience?
Definitely. It's definitely a collaborative effort because some of the product's design may solely exist because that's what the end consumer or end user wants to see in that product. So being able to manufacture something with that characteristic in mind may not be the easiest thing to do. And so then you have to figure out how to wrap all of that together so that it's a solid design, it meets the end user's needs or requirements, and then it's also manufacturable. So sometimes there's without that collaborative effort, it's definitively going to be a challenge. But if you tie all those groups together, you can actually solve a lot of problems with a product design and still meet the end goal.
Yeah. I would think that, I'm going to ask you about the challenges of DFM. And I would think that there are two groups that produce different challenges. One is if you're an OEM, you have kind of an in-house challenge. Maybe you have to get buy-in from various groups within your organization. And I would think in your world, as a contract manufacturer, the challenges are multiplied because sometimes you're just given a statement of work and a bill of materials and you're told, build this. And it may not be buildable or readily buildable. And that might result in either failures in the field, unintended failures in the field, or it might result in higher prices per assembly than would otherwise be. So what are the challenges, both from an OEM perspective as you see it and as you experience probably on a daily basis as a contract manufacturer in implementing a DFM?
So some of them are the same in both instances. Some of those challenges come into play where you have different philosophies between the design engineering groups and manufacturing engineering groups, where a board is heavily designed to maybe fit performance or functional needs, but completely violates anything related to DFM because the priority goal from a design perspective is meeting that performance requirement or something. A simple example is when you have like a connector that has to be in a certain place on the board that is in a location that you have to hand solder, you can't wave solder it. So that's kind of a simple thing where you have a performance or an end item, but getting that resolved in process, can be a challenge. From a EMS perspective, a lot of that's the same, but now you're dealing with usually a couple other entities in between the manufacturing group and the design engineering group. So in like our case, we may have to funnel through a program management team that at our customer site, maybe they only allow interfacing through a sourcing team. And then so we have to pass it through them and then get them into engineering. So until we can establish that engineering to engineering relationship, it can be a challenge. Right. Another big challenge or common challenge, I would say, is having DFM topic too late in the design process, which can prevent changes from being implemented that would have actually been fairly easy at the beginning. But because it's too late in the process, the effort now to make those changes could create delays in like launching a product. An example, one that we've experienced is there were some traces that were very, very close to a board edge, and there was a lot of concern that those traces could get damaged through processing. Unfortunately, being able to move those traces required moving numerous other traces to make room, and so the customer didn't want to enact those right away because that would delay the launch of that product by a couple months while the designer made all those changes and validated them. So having that earlier discussion about DFM is very crucial.
Yeah, I would assume that if you bring up after a product's already designed, DFM is probably a tougher sell, unless unless they are having major issues, reliability issues in the field, in which case they may have to look at it. If a product is already designed, is it too late for DFM? If there's enough motivation from the customer, can you implement a DFM process kind of in retrospect? Can you make maybe some smaller changes that would not severely affect the timeline, that could make some major improvements in how things are manufactured?
You definitely can. So you do have to look at DFM as a living concept, that it's not something that's done once and then it can't be touched ever again. For things like fab level changes, it may be more difficult.
Right.
But you have a lot of other items that you can touch during a product's life cycle. Certain components on the bill of materials that can be changed fairly easy because maybe they're using a standard footprint, but now a part's not available. Maybe you have to make some modifications like stencil optimization, so you can place a slightly different sized component, but leave the pads alone on the board because you made some changes to the stencil, so you can kind of compensate that. So there's things like that you can still do changes with during the life cycle. One of the most common ones is panelization changes. So if you have a panel layout of a fab that's not quite the best that it can be, those are a little easier to change in midstream, as long as you didn't do massive one-time buys with fab quantities, and depending on the volume. So panelization changes are probably one of the most common ways to make improvements with mature products, because it helps us dial in a process where to make that next level of improvement, you have had to build maybe a couple thousand before hey, we've gotten everything dialed in, we've built 5,000, but if we make this one panel change, it'll shave a little bit more off this production cycle time or whatever. And so in those cases, that's looking at DFM over the lifespan of a product. You can continually optimize what you're doing in a process perspective.
Sure. Scale means everything. The greater sample size we have, like any statistic, the greater sample size we have, the more we can see trends. And, in my world, I live in the cleaning world, and contamination removal world. And one example of kind of retroactive DFM would be to change the mask protocol on a board around bottom terminated components. The concept of window painting or building a kind of a mask gutter around certain bottom terminated component parts allows more easily the activators in the flux to outgas. They have a place to go, and that can reduce voiding and other types of things. And that wasn't really discovered until well after these boards are being manufactured, and the industry, once it was at scale, started realizing that they're having a lot of quality issues, in this case, voiding. And the application of a solution, which is really within the DFM category, was rather easy to make and benign to the rest of the product. Right? it was totally an inert thing, yet it made such a tremendous difference to a lot of assemblers. When in your world, when you're given, in your world meaning contract manufacturing, when you're given a product and say, okay, build this, and you have some design ideas, DFM sort of ideas, that could make the product easier to build, make your life a little easier, and probably the customer's product a little better. How do you go about, quote unquote, selling that idea to the customer? I would imagine one way is through a process I like to call guided discovery, which is giving a set of facts, and the customer comes to their own conclusion, which happens to be your conclusion. And that can be done by saying, okay, it's going to be $100 a board if we do it my way, or $1,000 a board if we do it your way. And suddenly your way has a lot of weight to it. But outside of that, how do you go about getting buy-in, particularly from customers that just say, it's your problem, you deal with it?
Right. So it definitely varies customer to customer. So we have some customers that are resistant to DFM changes unless it creates significant cost savings. They want to call their design done and just have it built. So that's a little bit more of a challenge. So it really depends on how they view the benefits of DFM, and as well as how open they are to that input in their design process or product lifecycle process. So we have some customers that welcome DFM in all steps of the process and involve us as early as possible. And so in those cases, we really try to leverage the benefits, like I mentioned earlier, and it could be cost savings, could be higher quality. And in some cases, we've had to make some changes that were under our control that did not require customer approval, but maybe had some expense, like wave solder fixturing or whatever. There's been cases where we have put the expense forward ourselves to kind of prove the point. And then once we're able to pass that cost savings on to them, kind of say, hey, here's how we accomplish that cost savings. So if you were to, purchase wave fixtures through NRE process earlier on, we can give you those cost savings earlier in your product life cycle. And we actually did exactly that with one of our customers that was very hesitant to want to pay for wave solder fixtures until we showed some very large cost savings by creating a much cleaner process.
I'm reminded of a guest I had on this show probably about a year or so ago, Chris Denny. He's from another small family-owned contract manufacturer, and they had a customer that really wanted their board built with black masking, right? Because they thought it looked cool. And they're like, sure, of course, we don't care, and so the CM in this case had to source the board, as typically CMs will be given that task. And they had just tons of rework. I think it was a bridging issue. There were just all sorts of solderability issues on that particular board. And they fought it. And they were reworking and reworking and reworking. Of course, reworking, A, costs money, and B, anytime you rework something, you introduce another potential liability. And finally, out of sheer frustration, they contacted the customer and they said, we just can't do this anymore. Can we just use green solder mask or clear solder mask and not do the black? And the customer says, yeah, I don't care. They thought that was an absolute technical requirement. And once they switched to a traditional solder mask, the world was wonderful, right? And that is kind of another example of going back and after a product is completely designed and changing it from a DFM perspective. What are some of the common misconceptions with DFM? What do people get wrong in the concept of DFM?
I would probably say one of the most common things is that every DFM topic or parameter is going to instantly create a difference or a cost savings for the product. In some cases, making a change for a DFM purpose or reason simply elevates the level of quality. So in some case, in the process. And so in some cases, as a contract manufacturer, not all of the cost of poor quality that occurs within a process is, charged back to the customer. It's on us as the EMS to ensure that our processes are operating at a certain level. If we're not operating the best, we can't charge our customers for that. That's our responsibility internally. And so some of the DFM input that we provide is simply to enable a stronger process that eliminates, random rework because of, instead of getting, 99.9%, product out of SMT, we're seeing 98%. And so, yes, that's a small amount, but if it's just a simple change that needs to be made on the design or with the bill of materials, that's almost a 2% change in quality that, doesn't require anything other than a simple design change that occurs once. And so those principles that may not directly impact cost, but gives the customer a higher quality product, which, like you just said, it reduces liability from a warranty RMA perspective for both parties. Mm-hmm. Usually those are some of the things that kind of get missed or that there's an assumption that, hey, if I make this change for you, I'm going to instantly see a dollar amount change that's going to benefit me as a customer. It's not always the case. In some cases, you're going to see an improved customer satisfaction over the next 5 years, as opposed to a direct cost improvement today.
Yeah, that brings up the old saying. I've said it several times on the show. We don't have time to do it right, but we'll find the time to do it over. Right?
Yes.
And doing it over is a lot more expensive than doing it right in the big scheme of things.
Yeah.
DFM seems to be, particularly from a contract manufacturing standpoint, from an EMS provider standpoint, seems to provide a pretty high degree of sellable win-win, because if things are easier to manufacture, that it's easier on you and your team, and your profit margins can be improved, and a well-designed part that is easy to manufacture will tend to fall into the reliability benefit for the customer.
Yep.
So and the customer will experience fewer delays from the EMS provider. So it does seem to land on both sides. It seems to be an investment that is benefited, that can benefit both the EMS provider, if that's the case, and their customer, the OEM itself.
Right.
Yeah, that's a good sellable point. First of all, DFM, I would assume, in a best case scenario, starts at the design process, right? And when I say design process, I'm not just speaking of circuit board design or semiconductor design. I'm thinking of when the product itself is born, when there's a genesis of a product. Hey, I got an idea. I would think that's where DFM should start. Is that typically where it starts, or is it normally a response to a problem?
It could be a mix depending on the type of design it is, but normally it starts at the design, because we do have, even with our customers that are resistant to a lot of our DFM feedback, they're still utilizing DFM principles in their design, so you can see that it's still occurring, even though the process from our side or our input maybe hasn't occurred yet. You can see that they've actually taken some principles and applied them in their design process, which of course is always the best place to have it start. The first step is always having the design group collaborating with manufacturing groups to ensure that the DFM does get implemented in the design process. And whether those are both in the same company as OEM or ODM EMS relationship, those two groups need to be working together. And then, of course, the next step, if you will, is being proactive about it. So, we encourage our customers to share their designs. When their designer is at a point where they're kind of sitting back in their chair going, you know what, I think I can take a breath with this design now. It's about ready to get wrapped up and do some final tweaking of traces and position of components and that type of stuff. But in general, it's almost ready. That's usually the point where we say that's where the designer should wrap up their design files, shoot it over to us and say, can you please give me a quick DFM review on this and let me know if I'm on the right track with everything, or is there a red flag that I need to move now before I call it done? And a few of our customers that actually do that, we have captured some items that would have greatly impacted the manufacturing cost of a product. In particular, one was the position and style of a connector that they chose to put on the bottom side just to make it easy. Basically was going to create 2 or 3 extra manufacturing steps in the process to handle that. And so we simply just said, if you just move that connector to the top side of the board where you have plenty of real estate, you eliminate this, and so your cost is going to be significantly lower. And the best thing about that is that particular designer, literally a couple weeks later, shot us 3 other designs that had been in their queue for a while. They just hadn't launched. And they said, hey, I've got the same connector on these boards. Did I do it right? Or what about these? And so that expansion, once you start that communication, can be very beneficial. And again, it gets it into the design process.
As an engineer specializing in DFM, what are some of the tools that you use?
So there's actually a lot of different software tools specifically designed to review PCB data for DFM analysis and other types of things. In our case, we have several software applications that are pretty much standard in the manufacturing industry. Internally, we do have Altium Designer. So even though we are not, we don't offer design services, one of my engineers, in his prior life, if you will, was a PCBA designer for a long number of years. So he uses Altium Designer to import customers' data and run some design rule checks and stuff that he's built. We use some products from Graphicode, GC Preview, and PowerPlace to analyze Gerber data and do a lot of color mixing with the layers to kind of see where spacing might be an issue and that type of thing. Our MES software is Aegis Factory Logics, so we can import files. That's where we merge the CAD and Gerber with the bill of materials to create machine programs and our work instructions for the operators on the floor. So that has some tools in it that we can leverage. And then Silicon Expert is a cloud-based tool that we use to analyze bills of materials to look at if parts are coming up end of life or obsolete, if how many alternates are available for a particular part. Obviously, if you look at an IC and there's 20 different alternates on the market, that's probably a good part to choose. Whereas if you look at one and there's one or two alternates on the market, you may want to revisit using that particular part or package size or whatever might be the limitation. And then, of course, in general, component data sheets and process material data sheets. If a customer requires us to use a particular RTV or solder or whatever, we'll use those material data sheets and application notes to analyze the process that product will have to go through. So we take all of that and then measure it up against our process capabilities and equipment. So in a lot of cases, a DFM review for us may not be the exact same as a DFM review for, say, a much larger contract manufacturer, because they may have different equipment, maybe have state-of-the-art equipment that was, purchased last week, et cetera. And so while our equipment is very up to speed and state-of-the-art, it wasn't purchased last week. So there are some changes and features. And so we try to also document the items that are, which are very rare, but there are an item for us as a DFM perspective, but may not be a general DFM. So that's good for the customer to know.
And I think the opposite can be true too. You said some EMS providers may have more sophisticated equipment than yours. Others may have legacy equipment, that they bought on auction. It was built in 1986 and at the earliest days of surface mount. Their DFM requirements will be far more stringent than yours.
Correct.
And yours might be less stringent than, or more stringent than someone with, the unlimited budgets, right? So
exactly,
it really is. You're right. It's really relative to who's building it and what resources do they have. You talked about
it, and we do actually have one of our selective wave machines, which was our first one that we purchased about 12 or 13 years ago. We still have it, and it's great for some of our boards that we manufacture for a customer that's in the oil and gas industry, and their designs are from the late 90s, early 2000s. And so that product works great on that machine because of its older architecture. And so in some cases, DFM for that type of a product works better for a legacy machine.
Sure.
So
well,
you have it from all perspectives.
When your equipment matches the timestamp of the product you're building, that's perfect, right?
Yeah.
You have an impressive amount of tools in your collection at Pride for DFM. Is that a typical toolbox with most EMS providers, or are you guys known to have, more DFM tools in your toolbox than a typical contract manufacturer might.
I think we probably have a broader set of tools simply because something like Valor, which is a great tool for DFM analysis all in itself, it's not an inexpensive piece of software, although it's very good and very robust. A lot of larger CMs are probably putting the expense towards a software package like that and are a little bit more dependent on the software for making some of those decisions. Whereas the software that we're using is maybe lower cost, or we're using it for multiple purposes. And so the cost justification is a little cleaner. And because of that, I have more people that are able to use the tools, and people that are more in tune with the process on the floor can use those tools. With Valor, you're probably going to have somebody that's a high-level manufacturing engineer or almost a design engineer that's heavily leveraging that tool to do the DFM analysis. Whereas in my case, most of my engineering and some engineering techs can utilize the software to do DFM activities. And so it really depends on the scope and goal of how an EMS company wants to accomplish their DFM purpose. And for us, because of the broad set of tools and the wide range of skill sets needed to use them, it works fantastic for us. So I can have somebody from an entry-level engineering technician to a senior engineer utilizing these different tools to get a lot of DFM input at various levels.
Mm-hmm. Yeah, excellent. I wasn't planning on asking you this question, but it just kind of came up. We're in a world of big data now. Data collection is cheap. Analyzing it is a whole specialty. Collecting it is not an issue anymore because memory's so cheap. And I've talked to a few experts recently on the subject of how to analyze big data, how to make that data useful, and things like that. Has the collection of data and every machine now collects data and it goes into some big portal and you pay a company a lot of money to make that data useful. Has that landed on DFM? Has the collection of literally hundreds of thousands of data points from dozens and dozens of different types of equipment, has that benefited DFM? Has it made it down to that level?
In some cases, definitely. So our SPI machines, solder paste inspection, being able to pull that data to see if we're looking at a particular component that we're having solderability challenges or reflow challenges with, being able to go back and look at the print quality of that component over 6 months, that really helps to see, hey, does the trends in our defects match the trends in the SPI data? If so, then, okay, that's a printing issue. That's not a design issue, or that's a stencil quality issue or whatever. Whereas if it's fairly steady across both of them, or there's like some mismatch, then you could say, okay, there's variability here that isn't coming from printing or reflow. There's something else going on. A good example is like the solder mask you mentioned. So though that kind of data, when used in conjunction with everything else, it can definitely give you other factors to look at. And I think for us, in most cases, we use that data to kind of confirm our suspicions. So when we think, hey, there's something going on here, let's take a look at SPI data for this reason. If we get data that confirms our suspicions, we know that we're on the right track. Mm-hmm. If we look at data and say, wow, that thing prints exactly the way we expect 100% of the time, then we know, okay, maybe we need to shift gears and start looking at something else as being a root cause. So definitely data and being able to analyze it for different reasons other than DPMO and yield is definitely valuable in a DFM perspective.
Let's talk about the intersection of a couple of DFXs. Yeah. One of them is yours, DFM, and the other is DFR, reliability. How does, I would assume the primary motivation for DFM is to make something more efficient in the manufacturing part of it. It's to make the manufacturing easier. Tell me how DFM morphs over into DFR, reliability.
Oh, that's good. So I think the easiest way kind of goes back to what you mentioned earlier is if you have a cleaner manufacturing process that results in higher quality, the liability of that product and rework or the chance of that product failing prematurely greatly improves. And so from a reliability standpoint, if DFM is second nature to you and you're really dialing the design and the process together, then warranty concepts start to reduce. There's going to be a much smaller impact with quality issues that occur outside or after the factory, I guess is the best way to look at it. And obviously there's going to be less rework that's done in process, which is, of course, a definitive improvement that you want to have. Anytime you're introducing rework, that's unnecessary cost, which is an expense that the manufacturer has to deal with. And then it also creates another risk factor about the quality of the product going out the door. Obviously, rework methods are, pretty standard, nowadays. So, performing rework on a component does not always reduce its lifespan or anything like that. But of course, doing less rework or less touch up or whatever it is always going to be the best case for product going out the door.
Let's talk a little bit more about reliability since I opened that door. Many companies, many people within those companies mix up the term quality and reliability. And one example that's kind of real time, I don't have an electric car, but the whole public EV charging station fiasco that's going on right now.
Right.
Statistics, press reports state that the uptime statistic on these public charging stations, and I'm kind of excluding Tesla because they kind of have their own,
right,
is about 70% uptime. That at any given time, 30% or so of public charging stations are broken. And
right.
That really is an inhibiting factor to the adoption of EV. If that's the direction our world is going, that's a real impediment to it. No one would buy a gasoline car if 30% of the gas stations were shut down at any given moment. So, the CHIPS Act, which was signed by Congress and several months ago, is putting billions of dollars into infrastructure, EV infrastructure, and their requirement, the strings attached to government money is they have to. I believe the percentage, and I could be off by a point or two, but it's somewhere around 96%. It has to have a 96% uptime, which I think is pitifully low for electronics.
Right.
That seems like, if 96% of airplanes, if 96% of air flights were reliable, it would be no one would fly planes, right? Because there'd be several crashes an hour. But at any rate, and I think that the manufacturers of these charging stations that are up 70% of the time, down 30% of the time, are not necessarily building bad product. The quality is probably there, meaning that they have a quality assurance standard. It meets that level of quality. I think where they got it wrong, and kind of the genesis of this long question, is they didn't understand the in-use climactic environment that those parts would be subjected to. They would be subjected to harsh environments, extreme cold, extreme heat, extreme moisture, extreme rodent, digestion of wires, roots coming up through the ground, cars knocking into them, people abusing them, things like that. So they may have built it per a decent quality standard. They may have had a DFM program that was perfect. It allowed them to build it. But I assume that DFM really only works if we can add the term reliable to it, like almost DFMR, like design for manufacturing reliable products, right? It's not just getting the product out the door. So that's kind of one example of how that intersection of reliability and manufacturability work, because just manufacturing it is one thing, that gets you paid, but that doesn't necessarily make sure you get repeat business, because all of a sudden, particularly in your world, and I'm not saying your customers do this, but typically in any relationship between a customer and a vendor, if something goes wrong, you end up getting, this going on, people pointing at each other. How, when you're doing a DFM analysis, is how the part is going to be used, where it's going to be used, the environment it's going to be used, the reliability expectations, the cost of failure, or any of those reliability-centric factors also factored into DFM?
Yes. So there are some of the products that we build that their in-use environment does create some, I don't want to say challenges, but factors that need to be taken into account. It's really where you have a customer call out IPC 610 Class 2 for their product, but because of the environment it's actually going to end up in, or could potentially end up in, it really should be treated as Class 3, or they should maybe have some additional call outs for the type of build parameters or assembly steps or inspection criteria. There should be additional content in the requirements to ensure the robustness of that product. A good example is something like a BNC connector. When you're dealing with BNC connectors on very thick boards, getting the 4 mounting posts to solder real well can be a challenge depending on the amount of copper planes inside that board. In some cases, you may have a customer that allows, IPC has a 50% solder fill requirement for something like that. But depending on the usage of that product and because of the design challenges, you may have a customer that's willing to accept a 40% or 30% solder fill because they want to reduce the thermal impacts on that board in process so that they don't, create a reliability issue by having perfectly soldered BNCs, but now you have a thermally stressed fab that may last 2 years instead of 5 years. So those are concepts that you have to kind of consider. What is this board going to see in its life once it leaves the building? And another good example of that is as simple as humidity. Yes, the product's going into an enclosure, but is it going outside? Is it going to be experiencing changes in weather? It might be great for a product in Northern California, but if you ship it to Southern Florida, that product's going to have some challenges. So depending on those types of environmental characteristics, the build process and changing it can directly improve the reliability of that product without actually changing the design. You're really just changing the manufacturing process used for it.
Yeah, you bring up a really good point, Andrew, and that is with the explosion of IoT, Internet of Things, there's a lot of consumer-grade products, arguably Class 1, maybe if you're lucky Class 2, but arguably Class 1, that are going out into the harsh, cruel world. The wearables and things like that. They go with humans and we go to scary places. And you're right. I think that there's a lot of Class 1 devices. Class 1, by definition, it can fail and nobody dies, right? That's
right.
Or there's really not a lot of damage other than maybe the company's reputation. But they're not surviving. They're failing miserably because they're built to Class 1 standards, and Class 1 standards really didn't incorporate harsh environments and potting or conformal coating or whatever is added to that. It's probably not a solderability issue. The solderability requirements on Class 3 are different than Class 2 and different than Class 1. But there almost needs to be a couple of guests on my show a while back, Phil Zarro and Jim Hall from ITM Consulting, said, we really need a class 1.5 and a 2.5, to mid-grade. And I'm almost thinking that we need almost like a class H, harsh environment. And that harsh environment could be thermal, moisture, shock, things like that. And again, class 3, we think of military and medical and maybe high rail telecommunications, things like that. But we don't necessarily need all the requirements of class 3 on a IoT device, right? But we need some of it. So I think with the explosion of IoT and the proliferation of electronics everywhere, it might be time for IPC or some body to maybe relook at how we classify these things. And I think we need well over 3 categories than we currently have right now.
And we actually have a customer that most of their products are class 2, but we actually call it kind of class 2P, which is preferred.
Yes.
So they're asking for class 2, but they really only want to see preferred criteria in any of their products. So they're, we kind of treat them as a class 3 customer just to make it simple.
Yeah.
But they call out class 2, but anything that's not all the way at the preferred level in that acceptable or process indicator areas, those types of items, they don't really want to see anything other than true preferred or above. So we actually treat that customer as class 3. So then there's no issues or concerns and everything. And so we work with them on that as a relationship, moving forward, so that it's very clear between both parties, how things are being called out versus what the true expectation is.
Sure.
So that's definitely a good way to look at it. IoT products are a good example, especially when you look at in the hobbyist world or DIY world. There are so many electronics, small microcontrollers and IoT wireless type devices that you can buy from Amazon, very cheap. But they might only last 12 months because they're not meant to be, treated as a wearable, because, it may work fantastic, but with a lot of vibrations and shock, as a wearable, the solder joints could, see much greater amounts of stress than the quality levels used to manufacture the product.
Yeah, take a Raspberry Pi microcontroller or something and throw it into a harsh environment, and that's not really the ideal scenario that the designers of that product were considering. I would assume. That's just a general assumption. We're almost out of time, so let's end with a couple more questions. Can you give me, without throwing any customers under the bus, protect the guilty or innocent, whatever applies. Can you provide like a real anecdote, perhaps, where your company stepped up and said, "Hey, we can do this better," and the customer experienced some kind of windfall from that?
Right. Actually, I have one that's a pretty good example, and it's pretty straightforward because it involves panelization, and so I use it as an example quite frequently. So the customer is consigned, so they actually purchase the fabs and all the raw materials, supply it to us, and we build the product. So their fab house was given the ability to make the panel layout based upon an expectation of, I need this fab to be the lowest cost. And so the panel was done as a 6-up array, and it wasn't the best for manufacturing. And so while we could do the whole panel in SMT, we actually had to depanel it partially in half to 1x3 arrays to be able to produce it on slide line because of some overhanging connectors. And then we would finish the depaneling prior to the hand soldering and testing functions. So my team actually came up with a panel layout that would be ideal for the entire process. And I think it was either a 2x2 or 2x3 panel, or not 2x3, 2x1, that had rails, et cetera, for conveyance, et cetera. So very clean from a process end to end. So we gave that to the customer, asked them to review it. They had it requoted by the fab house. The price was going to go up, something like 80 cents for I think something like a $2 fab. So that was like a big increase for them. So they were like, okay, no, we're not doing that. So what we did is we actually reevaluated and quoted that assembly as if it was penalized in the ideal format, presented them a cost that was actually about almost $2 cheaper than the original cost. And this is a high volume product, mind you. So it's a, 500 to 1,000 a month, and everything. So it was a noticeable difference for the customer. And it was on a product that very, very tight, cost margins for them on this product. So obviously when they're like, okay, wait, so we spend a little bit more on the fab and you're going to more than double that, in savings. So of course they went ahead with that change. And so we're able to have a much cleaner process for that. And one of the things that came out of that is they started going back through some of their other designs and going, hey, what about this particular board? We'd love to have a lower cost on it. Can you guys change the layout for us and will we get a lower cost? And so it started further discussion on other DFM topics because we were able to make a noticeable difference from a cost perspective. So that one, I guess another DFM topic is rather than focusing on individual components and lowest cost, what is your lowest total cost? So in this case, their fab price went up, but their total cost went down well more than what the fab cost went up. Mm-hmm. So from a design perspective or a buyer perspective, as at the customer, that's not going to be seen to them. Why would they want to make something cost more? Well, because manufacturing is going to cost less. So that's where you dovetail those two together. So that occurred a few years ago, and with that particular customer, we have a much stronger relationship from a DFM and early design involvement. So their more recent designs, we've been involved very, very early on. And so we've been able to prevent some other design challenges that would have created unnecessary costs.
And finally, we're almost done. Last question. And I am known. I do have a reputation for asking several last questions, but I do think this is my last question. What are the future, from your perspective? What are the future trends in DFM in terms of technology and in terms of adoption?
So, from a future trend as, hey, what do we need to be looking at? Thanks to COVID. Supply chain became a family kitchen term. It's not just in certain industries; it's everywhere now. So part availability and part obsolescence and those types of items have become a much stronger DFM topic. Used to be you could design a standard set of components into your board and you're rock solid. Now you may present that to your EMS provider and they go, yeah, your BOM looks great, but 20% of the parts are obsolete in the next month, or we can't buy them for 52 weeks. Right. So that's becoming a much stronger topic, in the field from DFM. And I think even going further into the future, other topics that we're starting to see is sustainability, eco-friendly type topics, removing certain types of chemicals in the manufacturing process, maybe reducing the amount of hardware that's in a design to make it user-friendly from the end point, as well as reduction in waste going to the landfill, so many years after the product is used. Or environmentally friendly plastics. There's a lot of different types of advances in plastics now that can be used or leveraged for that. And then I think that one of the other ones that we're seeing a little bit, I see it more as still a ways out there, but it's a design in a product with salvage concepts in mind, so that you have very expensive components that you may want to remove from a product, so long after that product's been built. So you design that board in a way that those components can be extracted or removed in a recycling process. So it may not get used for the same type of architecture, but maybe, into other countries where they can leverage very expensive parts in, refurbished type environments or whatever. I have seen a few topics with a couple customers that was one of their topics, especially dealing with very expensive processors or custom modules like GPS or something of that nature.
Excellent. Well, we are out of time. Andrew Williams, Pride Industries, thank you so much for sharing your insight on DFM and other DFXs with me and my audience. I really appreciate your knowledge and your willingness to share that knowledge.
Oh, you're very welcome. I love to share what we do, what our expertise is, and how we do it while meeting our mission so that we're improving society as we do what we do.
Excellent. And for those of you who are listening to this podcast on your favorite podcast app, go to the show notes on your favorite podcast app and you'll have information on Pride Industries and contact information there. Also, if you're watching this on the YouTube channel, right down here somewhere that says show more, click the show more button and we'll have contact information there as well. So again, Andrew, thank you so much for your for generously donating all that experience to me and my audience. I really appreciate you being here.
Yeah, you're very welcome. Happy to do it.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Our episodes have been downloaded more than 35,000 times, and I remain ever grateful for your support and encouragement. Don't miss an episode. Listen and subscribe to the Reliability Matters podcast on your favorite podcast app, or watch it on the Reliability Matters YouTube channel. If you're watching this on YouTube, be sure to click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks also for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments and episode suggestions to Mike at mikeconrad.com. Just remember, that's Conrad with a K. Once again, thanks for listening or watching. Until next time, stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. And I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.